Okay, dear student, let's see what is there in this question. A football player kicks a stationary ball of mass 0.45 kg towards a wall. The initial speed of the ball after the kick is 19. The ball does not rotate. Air resistance is negligible and there is no wind. Okay, so they have given all the conditions there. Air resistance is negligible means that there is no loss of energy due to friction or viscosity. Usual thing. Okay, there is no wind. No wind means that there is no drag force. There is only one force which is acting on the body, on the ball once it is in the air, and that is the weight, which is the essential condition for our projectile motion. So all the other formulas are valid in this question. The ball does not rotate. Ball does not rotate means that there is no rotational kinetic energy. So although this question is for SL, but in the HL there is like the topic A4, so we need not to be concerned with the rotational kinetic energy. So even that will be consuming some part of the energy, so we are not considering that also. Under those conditions, these formulas are completely valid. Do you see that? Like there are people, those who do the IAs of some of the other kind of the experiment that they see, but they do not fulfill these many conditions while they are doing the experiment. And they only apply the SWOT equations. And then they feel like, why my answer is not coming correctly? Why? Because there are so many energy losses and we have not incorporated them. Okay, let's go for the question now. The player's foot was in the contact for 55 milliseconds. So, as I have told you in many other videos, whenever there is a time given like this, the time for the contact of the collision, something, we definitely refer to the formula F is equal to change in momentum by change in time, or might be he would be talking about the impulse, which is F delta T, which is equal to change in momentum. This is what are the formulas which are already coming into my mind now without even reading the question. Now, calculate the average force that acts on the ball due to the football player. It means that indeed the question is about the force, like what is the force which is applied on it. So we will find the change in momentum because impulse is of course not given here. So we will find the change in momentum, the time is given, divide them and find the force. Wherever there is this delta, we always find the average things, so we don't even worry about that. So the initial momentum of the ball is zero because it is given that initially before the kick the ball was not moving, it was at rest. Afterwards, the mass is 0.45 kgs and it is moving with the speed of 19 meter per second. So this is the final momentum with which it is now moving. Whatever be the direction, we don't care about that. Why? Because initial momentum is zero. If initial momentum was not zero and it had some other direction, at that time it could have been a problem for us. But that seldom happens in IB. So initial momentum is zero, final momentum is this. We are just going to subtract them to find the change in momentum. So our change in momentum will be given by 0.45 into 19 divided by the time it takes. The time is 55 milliseconds, so 0.055. This will give us the answer, and we will round it off to the two significant figures. So according to the calculator, the answer is coming out to be 0.45 multiplied by 19. Yes, I'm getting the answer as 155.45 Newton. Okay, so we can't get rid of anything here, even if you want to round it off. So it will be three significant figures minimum. So it will be 155 Newton. This will be your answer. Let's see what is the answer given in the mark scheme. You see, do you see this? They are not writing it as 155, they're writing it as 160 because you want to have two significant figures. That's it. Otherwise, everything is the same. The mass is 0.45 and the velocity is 19. The time is this, exactly what we have done. But do you see how they have rounded it off? Like I was saying that the answer could be 155.45, so I rounded it off to 155, but it was still having three significant figures. So it is more than 55, so you round it to 160 Newton. This is how you do it in IBs. Two significant figures, very clever. Okay, so we have done that. Now moving next. The ball leaves the ground at an angle of 22 degrees. The horizontal distance from the initial position of the ball to the wall is 11 meters. Calculate the time taken for the ball to reach the wall. It means that we are referring to this diagram once again here. So the velocity given is 19 meter per second. The angle is 22 degrees as it is given in the diagram itself, and the distance is 11 meter. It is also given here. So you want to find the time it takes to go to the wall. In such cases, we only talk about the horizontal motion. This is a projectile, yes, the oblique projectile motion, and the velocity can be divided into two components here, but we will concern ourselves only to the horizontal velocity, not with the vertical. So we don't care about what is the height at which it is striking. So we are only concerned with the distance of the wall. So this distance we would be going for the horizontal velocity. Horizontal velocity will be 19 cos 22 degrees, and the distance is 11. So what will be the time taken? It will be distance divided by speed. That's it. Why? Because there is no horizontal force, there is no acceleration. So the distance is 11 meter and the time is 19 cos 22. So this is the time in which the ball will reach the wall, like whether it is going to shoot like this or whether it is going to go like this, that we will see in the question if they are asking that kind of thing. But it will be reaching this point in this much seconds. Height doesn't matter. That becomes a different criteria altogether. Okay, so let's see. And let's see how they have done. Yeah, they have done in exactly the same thing. 19 into cos 22 is the horizontal speed. They divided the distance divided by speed and they get the time, which is 0.62 seconds. Now, the top of the wall is 2.4 meters above the ground. Deduce whether the ball is going to hit the wall or not. The time is 0.62 seconds. Yes, this is the diagram now. So as earlier, um, I have drawn the components here. So this is one component. This will be the another component here. This time, because we literally want to find the distance where the ball is going. So there is a possibility that the ball will be like, it might be going and hitting the wall like this, and it might pass over the wall like this. So we have to see whether it is passing over the wall or whether it is hitting the wall. We can find it that in this much of the time, what is the vertical displacement that the ball is covering in the time 0.62. What is the vertical displacement? So now we are only concerned with the vertical motion. I would be applying the Stewart equation, S is equal to ut plus half at square, and the sign convention also needs to be written here. So the upward is taken positive, downward is taken negative, because the ball wants to go up but the gravity is not letting it go, so that will be negative. Otherwise the sign convention completely bases itself on your fancies. You can choose whatever you want. So the displacement is in the upward direction. We can write positive h. U will be 19 sine 22 and the time value is 0.62 plus half. Gravity is taken as negative into time square, like 0.62 square. This is what is happening here. This is the height h. So you want to find the height and we will see if this height is lesser than 2.4. If it is lesser than 2.4, then it is definitely going to hit the wall. If it is more than 2.4, it will pass over the wall. That is the philosophy. So we just find it. So I'm not doing the calculation here again. You can do it by yourself. I will show you the mark scheme, how they have done. Yes. So the initial vertical speed is 19 sine theta, which is 7.1. And then you apply S is equal to ut plus half AD square, exactly the same thing that we did. Ut minus half gt square. And it is coming out to be 2.5 meters, which is clearly more than 2.4, which means that ball is not going to hit the wall and ball will be moving over to the wall. So your answer is this. It is 2.5 meter. This is how we do it. So I created the equation. You have calculated in the calculator. You would be getting the answer as 2.5. This is how we do it. Is there any other part of this? It's so long. Okay. In practice, air resistance affects the ball. Outline the effect of the air resistance has on the vertical acceleration of the ball. Take the direction of the acceleration due to the gravity to be positive. So downward will be taken positive, the upward will be taken as negative. It is already given there. That is why we are choosing it like that. Now, outline the effect of the air resistance it has on the vertical acceleration. See, the gravity is downward, so gravity is pulling it downward. It is going down. So when the ball will be moving a bit downwards, there will be a drag force because of the air in the upward direction. It means that the downward force will be the weight, and the upward in the vertical plane, there will be a drag force which will be acting there. So if this drag force is acting here, it means that the net force downward will be lesser. It means that the acceleration now, vertical acceleration for the ball, will be lesser than gravity. Okay, this is how we do it. And let us read what is written here. Air resistance opposes the direction of the motion. Air resistance opposes the velocity. On the way up, okay, I forgot. I've just taken the when it will be going down. So if it is going up, the drag force will be acting downward, so it will not be able to reach the same height. So the way up, the acceleration is increased, like the downward force is increased. It is weight plus drag. So it is greater than the gravity, and that is why it will not be able to reach the same height. On the way down, the vertical acceleration decreases. I have given you the explanation for that, because when the ball is coming down overall, so there will be a drag force and the upward force, so the acceleration will be smaller than g, but anyways still the ball will be falling down. Okay, so this is over. I think there is one more question. Okay, the player kicks the ball again. It rolls along the ground without sliding with the horizontal velocity of this. Oh my god, now it talks about the rolling motion. So the horizontal velocity is given as 1.4 meter per second. The radius of the ball is this. Calculate the angular velocity, state the appropriate unit. Okay, dear students, so this question is quite dicey. I don't understand, like, because this was SL question as far as I remember, and this question D, it belongs to the topic A4, but A4 is not the part of SL syllabus. So I don't know where is the error. It is written that this was asked in SL, but it cannot be SL. It will be HL then. So this part of D will be HL question, and let us do it for the HL students now. So in the case of perfectly rolling motion, see, it's very simple. We are going to use V is equal to R omega. So even if you don't know the rolling motion, you can do it. The velocity is given as 1.4. The radius of the ball is given 0.11, and you can find the omega. Very simple. But it is more important for you to understand from where is this formula coming. This is not the same formula that you know. It's different. Why is it different? Listen to me. Now, this is the perfect case of rolling. It means that this point is not moving at all. This point is moving with a certain velocity v. So in the case of rolling, what happens? This point, it is moving with the speed of 2v. This point, which is in the contact of the ground, because there is no sliding, there is no relative motion between the two, so it is not moving like that. So we can say that the translational velocity here at this point is zero, because they are not sliding. They are actually in contact with each other and they are not sliding there. So there is no velocity. So this is the velocity profile that exists here. So every point here is moving with so and so velocity here. The center point here is moving with the velocity v, which is given to us. Now, in this case of perfect rolling, we have this condition that v is equal to r omega. We have to apply this formula there, where v is the velocity of the center of the circle. When we were talking about like v is equal to r omega from a horizontal circle point of view, v is the tangential velocity, r is the radius, and omega is the angular velocity at the center. And v is the tangential velocity of the bob. But in this case, it is not the case. The formula on the surface looks similar, but they are not the same. Because in the case of rolling, we are not talking about the tangential speed, we are talking about the speed of the vehicle, the speed of the tire, the horizontal velocity on the ground. So that is this. So it is v is equal to r omega. If you need more information on this, you have to refer to the lecture series for the topic A4, which is already uploaded there. And if you are, of course, a member on the YouTube channel, so you can watch that video. So v is equal to r omega, and the velocity is 1.4, the radius is 0.11. We can find the omega value. Let's see what have they done. Okay, they have not written anything, so our answer was 1.4 divided by 0.11. V is equal to r omega. Yeah, this should be the case. Yes, of course. And I'm using my calculator to find the value. 1.4 divided by 0.11, and the answer is 12.72. 12.72 meter per second, radian per second is the speed that we are getting, and 12.72 when converted into two significant figure will be taken as 13. So this is how we do this question perfectly. It was a long question indeed. Okay, dear students, thanks for watching the video. This is Professor Varun. I hope you like the video. Keep on watching the videos, keep on learning. You got to have 7 on 7 in your exams. All the best. Bye.